if we pursue the target of longevity, perhaps, and we call ourselves the anti-aging doctors, then we should focus on the catabolic processes, so we're supposed to stimulate the AMPK and the rest, because that is sort of the longevity gene, right? With all the cascading the consequences that it will trigger, the autophagy, glycolysis, the mitochondrial biogenesis, and so on and so forth. However, if we want to call ourselves regenerative medicine doctors, then we have to understand that we have to put the patient in the anabolic state, because when the person is, or cell, or tissue, or the body as a whole is in the catabolic state, it cannot regenerate itself, because regeneration means creation of new molecules, new macromolecules, and that is definitely the anabolic pathway, and that is regulated via the mTOR gene. So the cycling of the catabolic state and the anabolic state that we should put our patients into, I believe, is the essential in the modern contemporary practice of holistic, genetic, molecular, precision, personalized medicine, which all in general can be called as regenerative medicine. And whether person, organism is an open biological, dynamic biological system, or the cell, whether it's in a catabolic state or the anabolic state, the mitochondrial function is ultimately involved in it and plays a crucial role in it. So what is mitochondria? Of course, from the point of evolutionary biology, we know that mitochondria is a parasite that turned into the saprophyte. It's a cell that lives within the cell. We call it the power plant, because it's involved in energy production. Indeed, the glycolysis with generation of the oxidized NAD, which produces quite, I would say, a minimum yield of the energy. The ATP is just the ATP molecules. And then the entire Krebs cycle that produce additional, if I'm not mistaken, 24 ATP molecules, and the end process of that, the breakdown of the macronutrients into the water and basically the thin air, the oxidative phosphorylation. It all is happening inside the mitochondria. In case if the patient or the cell or the person is completely in a catabolic state and it's fasting, it's conserving energy, and it's sort of using the accumulated molecules as a nutrition, we call it the fatty acid oxidation. Mostly it happens during the fasting state. It also happens inside the mitochondria.